Alrighty, y'all, welcome back to another video, and in this tutorial we're going to be talking about the blockchain, blocks, and the mining process. So to kick things off, we already know that the Ethereum network is composed of nodes, and we also know that users can connect to the network through these nodes. Now once connected, users can create transactions and send them to the network through these nodes. Now once a node receives an incoming transaction, what it's going to do is actually send that to all other nodes that it's connected to. So let me get some cool green arrows going here. So say that this node right here received this transaction. What it would do is it would send it to this node, and this node. And these nodes, upon receiving the transaction, they would send it to all nodes that they are connected to. So that's how a single transaction coming from a user to a single node is essentially going to propagate throughout the entire network until every single node receives that incoming transaction. Now, as more and more people begin to send transactions into the network, each of these nodes, upon receiving these transactions, are going to start combining them into a potential block. So for now, we can think of a block simply as a list or a group of transactions, although as we're going to see in just a second, there's actually a bit more to it, but for now, we'll just stick with the simple definition of a potential block is simply a list of transactions. So either way, once a node has a block of transactions, what it can do then is begin validating and executing those transactions. And by validating, I mean ensuring that the data is properly formatted, that the user included enough fees, so on and so forth. So this is when things get interesting, because before these transactions can be considered finalized, each node is then going to attempt to solve a difficult puzzle, and this puzzle is going to require a lot of computing power. Now, by solving this puzzle, nodes can prove that they did work by using computational resources. And by the way, even though you couldn't see, I had quotes around prove and work in that sense, and that's because this process of trying to solve this puzzle, this is called proof of work. So to produce a valid block, a node not only needs to validate a list of transactions, but also provide a correct solution to this difficult puzzle. Now, whenever a node is able to produce a valid block, then what it's going to do with that block, well, a couple different things. The first thing it's going to do is it's going to add it to its own blockchain. And we'll talk a little bit more about this blockchain in just a bit. But for now, just remember that it's going to take that valid block and it's going to add it to their own blockchain. And on top of that, they're also going to take that block and send it out to all other nodes that they are connected to. Now, these nodes, upon receiving this new block, they're first and foremost going to validate it to make sure that the results and everything else is good, the solution is correct, so on and so forth. And as long as everything looks good, then they are going to add it to their blockchains as well. So this process is what's known as mining. It's the process of generating a valid block to be added to the Ethereum blockchain. Now, the node who successfully mines a block is going to be rewarded in Ether. So in this case, it would be this node right here. So this is why in the Ethereum network, we have a lot of nodes always trying to find that next block. Because if they can mine that first block, again, validate those transactions and solve the puzzle faster than all other nodes, then they're going to be rewarded with Ether. So now that we understand the basics of how these transactions are validated, how they're grouped into blocks, and how those blocks are propagated throughout the network, let's go ahead and take a closer look at one of these blockchains. Now, before we dive into the blockchain architecture, there are a couple things that I want to mention. The first is that the fields and the exact data that I'm going to be talking about as part of each block, it's not 100% technically correct. There are a lot of additional fields, mostly for security and validation purposes. Here, we're taking a look at a very high-level overview, and also some of these things aren't technically correct. For example, there's not a field called solution in here. So again, this is more conceptual. Later on, if we need to, we'll take a look at the actual individual fields and break them down like we did for the transaction object earlier on, but just want to point that out. Now, that being said, let's go ahead and add two more fields to our block, and that is one block number. And I don't think I really need to dwell and explain this too much. you can kind of see that a block number is essentially, well, I don't even know how else to explain it other than block number. If you view these blocks as items in a list, it's really just their positioning starting at 0. So 0, 1, 2, next one would be 3, so on and so forth. Now, another field that is indeed in each block, again, this isn't just conceptual, this is actual value in these blocks, is a hash value of its parent block. And by parent block, I mean that the block that came before it. So first, this may seem kind of strange, like why do we need to include a hash value of the entire block that came before it? What's the point of that? Well, the reason for this is actually related to the overall blockchain architecture. By hashing the previous block and including that hash value in the subsequent block, what this allows is for the entire blockchain to essentially maintain the order of which block came after each other. In other words, it's kind of like a big linked list. And by hashing it, you're essentially just maintaining the order of blocks in the blockchain. So through this entire mining process, or in other words, the creation of the Ethereum blockchain, every single node in the network is able to reach consensus on each new block and ultimately the blockchain as a whole. Now, a couple last things to point out. The first is that not all nodes in the Ethereum network are indeed miners. Miners are the nodes that are using their time and their computational resources to process transactions in an attempt to produce more blocks. However, there can be nodes, and in fact there are in the Ethereum network, that are interested in mining or finding more blocks. And an example of this is, let's say that we had a node that just wanted to listen for incoming transactions. Maybe they had some like API service and they were providing data to people. In that case, they really aren't interested in finding new blocks. They really just wanted to, gather data, be part of the network for those reasons. So that would be an example of an Ethereum node that wasn't a miner. In other words, they weren't trying to solve any puzzle. Now, the last thing I want to point out is that the Ethereum network, right now, it uses a proof of work consensus mechanism, and that is what we described right here by essentially solving this puzzle. Now, on that note, proof of work is actually being phased out of Ethereum in favor of something called proof of stake. And the reason for this, well, one of the primary reasons is that they want to decrease the amount of energy use, because this process right here, it actually requires a lot of energy. So Ethereum is transitioning over to a different consensus mechanism that will essentially get rid of this puzzle solving process and eliminate the need for proof of work. So for now, I think that puts us in a good position, have a pretty solid understanding of blocks, the blockchain architecture, and really the mining process, proof of work, so on and so forth. So for now, thank you for watching. Don't forget to subscribe, and I will see you in the next video.